Okay, so right now I'm working with adding multi-digit whole numbers, and we're going to use the standard algorithm for this. For the standard algorithm, it is so crucial that the students already understand place value, because this does rely heavily on place value and regrouping those tens into the next place value place. So to teach place value, I always love to use the place value blocks. I don't have any with me. That would just be too convenient. I drew some here. Obviously, these are the ones. And this is the tens bar, I think they call it. This is the hundreds. It represents the hundreds and the thousands. So before starting them with the standard algorithm, it's good to remind them that once you get 10 ones, 3, 4, 5, 6, 7, 8, 9, 10, that these can better be represented with a bar. And this is the tens place. So once 9 ones is okay, but once you get to 10, you should regroup them this way because it's a lot easier to work with one bar than it is 10 little cubes. Same thing with the tens. Once you hit 10 of these bars, you can actually use a hundreds, I don't know what they call this, the 100 square, because it's easier to work with one square, and this isn't drawn to scale at all, so ignore that. But it's easier to work with one square than it is 10 of these little bars. The same thing for the hundreds to the thousands and the thousands to the 10,000s. The thousands is a cube, so obviously 10 of the hundreds is going to equal the cube, all lined up in there. So just remind them, because this relies so heavily on place value, that a 10 in the ones place is the same thing as 1 in the tens place, because there would be 0 in the ones. That is what place value is. Just keep reminding them of that, because with the standard algorithm, they're going to have to regroup, and it's going to be ridiculously confusing for them if they don't understand place value. They're just going to memorize a rule, and you never want that to happen. You want them to understand why they're doing what they are being taught. So we're going to start off with a number that I would not give them. Let's make this 7. When I'm first starting to teach it, obviously I would give them a much smaller number. But let's make this a 9, no, 2. How about that? This is going to show the regrouping, and that's basically what I'm making the video for. So when given this, I also like to show students a tape diagram. Now, these didn't help me when I was in school learning how to add, but they did help other students because it showed, this is supposed to be a little piece of tape. It shows them that these two numbers that they're adding are going to equal or be the same as this bigger number that they are trying to find. So 312, what you're trying to do is draw these in relation to each other on the piece of tape, which I didn't measure this out, so it's not drawn to scale at all, but the 3,617 is obviously bigger than the 492. So it serves its purpose. So you're showing them that this piece of tape is going to be equal to or the same as this piece of tape, but we do not know yet what this sum is. So I'm going to label it with an A. We're going to move on to this place value chart. I love showing these first before I show them how to do this, because I feel like when they're working with the numbers, they're just memorizing what you do and copying it. Whereas if you show them the place value chart first, they can visualize it and they can understand why they're carrying that 1. So I like to start, when I use a place value chart, I always like to start with the number farthest to the left. So in this case, that would be the thousands place. But I do know several people like to start with the ones place instead. Either works, just make sure you go down the columns and keep the ones together, the tens placed together, the hundreds placed together, and so forth. So I'm going to start with the thousands. So I have, in 3,617, I have 3 thousands, or 3 in the thousands place. I have a 6 in the hundreds place, so I'm going to draw 6 little bubbles here, or discs. Most people call them discs. A 1 in the tens, and a 7 in the ones place. Now at this point, it would be very beneficial to remind them that 3 in the thousands place represents 3,000. A 6 in the hundreds place represents 600. 1 in the tens place represents 10. And 7 in the ones place represents 7. Because when they're regrouping, they're going to know that 10 is too big of a number to put in the ones place. So they have to move it. Okay, let me get a different color. Okay, so now we're going to move on to 492. So I don't have any thousands, so I'm going to leave that one. Go to the hundreds. I have 4 in the hundreds place. I have 9 in the tens place. 2, 3, 4, 5, 6, 7, 8, 9. And I have 2 in the ones place. Okay, so now they can go ahead and they can add up the columns like you would tell them to do with the numeric form. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. You know that's how kids are going to do this. They're going to count it up instead of adding 7 plus 2. So we have 9. Then you can ask them, is this number okay? Is it a single digit number? Yes, so we can move on. In the tens place, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you can ask them, is this number okay? Can we have a 2-digit number? No. Why? Because 10 in the tens place is the same as 1 in the hundreds place. So we need to move these over to the hundreds place, but of course when you move 10 over here, it becomes 1 because 10 in the tens place is the same as 1 in the hundreds place. 10 tens is the same as 100. Make sure that they understand why they are moving these. So this is incorrect. So you can tell them to count how many discs they have left after they've moved the 10. And obviously we have nothing, so I'm going to put a 0. And we can move on. In the hundreds place, we have 1, 2, 3, 4, 5, 6, 10, and then 11. So, is this number okay? Is it a single digit number? It is not. So we need to regroup. So we're going to take these 10 and we're going to bump them over to the thousands place. 10 hundreds is the same as 1,000. So now that we've moved the 10 over, this is incorrect. I have 1 dot left, and it's the one that I carried over, or disc, sorry, that I carried over from the tens place. So I'm going to put a 1 here. Now I'm going to move on to the thousands place. I have 1, 2, 3, 4. Is this number okay for the thousands place? Yes, yes it is, because it is a single digit number and we do not have 10 to carry over to the 10,000s place. So my final answer is 4,109. So now I can put up here that A equals 4,109. And this right here shows them that the equal sign doesn't mean just equal, because if they don't understand what that means, it's not going to click with them. This also means the same as. Both sides of this equation, if it was sideways of course, are the same. These two numbers together are the same, is the same as this. So the tape diagram, like I said, it didn't click with me when I was learning, but I can see how this would benefit visualizing. the standard algorithm, visualizing addition in general. So now we'll move on to the numeric form of the standard algorithm. Like I said, this is the standard algorithm as well. It's just a picture version of it, and it's a more kid-friendly version to work with when they're first learning. Okay, so remind them that they're adding down the columns, not rows, just like they did with the place value chart. So this is my ones place, so I'm going to add up my ones place. 7 plus 2, that gives me 9. Is this number okay to stay in the ones place? Yes, because it is less than 10, so I do not have to regroup. Now I'm going to add the tens place. 9 plus 1 gives me 10. Is this number okay to stay in the tens place? No, because we hit a 10, so we need to regroup. So, just like down here, when I added this little dot or disc to the next place, I'm going to add a 1 up here to add in. It's the same concept, but like I said, if you tell them to just leave the 0, carry the 1, they are memorizing a rule and they're not understanding the concept of what they are doing. So yes, you leave the 0 because there's nothing left over after you move that 10 to the hundreds place. So now we can carry on just like before. We're going to go to the hundreds place. 6 plus 4 is 10 plus 1. That gives you 11. So a lot of teachers leave the 1, carry the 1. Like I said, they need to understand the rule behind that. You are leaving 1 because you have 1 left over after you move this 10. So 11, and then we can move on. 3 plus 1 gives you 4. So I got the same answer that I did down here. This one I probably got a little bit faster because I didn't have to draw out all of the steps, but this does help them visualize it a little bit easier and help them understand why they're moving that 1, why they are carrying that 1, and what it means to regroup.